So, okay, today we're going to start the unit number 3. In this unit number 3, you're going to learn how to classify matter according to its composition, and in addition to that, you're going to learn how to separate mixtures. If you were in my physical science class, you have an idea of this topic because we were doing this when you were taking physical science. Still, we are going more in depth now. Okay, so first, I'm going to discuss the course structure. So we are starting over here, unit 3, and then you have this week and the next week to finish that unit. If you look over here, let me see, okay. If you look over here, part of this course structure is a lab about physical and chemical change. If you look on Ingenuity, you don't have like a format to complete your lab report. Consequently, you're going to be completing the lab report following my format, the lab report format that I gave you the other day. Am I going to help you completing this lab report? The answer is no. Okay, so you are on your own. It's giving you the procedures. They're discussing the purpose of this lab, and based on that, you will have to create your lab report. Remember that you have to put your title, the abstract, the background information, all of that, and then if you are gathering data, quantitative and qualitative, you will have to reflect that in your lab. But later we're going to talk a little bit more about that. The first part of the unit is classification. See, classification of matter according to its composition, and we're going to cover that today. After today's lesson, you're going to be able to complete, okay, this lesson over here with the quiz, and then you're going to be able to complete part of the lesson that you have over here in lesson number 3. So today we're going to cover lesson number 1 and part of lesson number 3, okay? Then we're going to move to lesson number 2, and finally we're going to go over the techniques that you're going to use to separate mixtures in general, because solutions, they are part of mixtures. Now, what are the grades that you're going to receive for this assignment? As usual, a summative assessment, for your overall grade. One more time, I'm going to put a stress on this. Overall grade, assuming that 100% of the lesson or the 100% of the unit has been covered. I know what you're going to say. Ms. Ramos, you're teaching this to us, but then we have to go back to this lesson, and then we have to watch the video one more time, even though we know the topic. It is what it is. Okay, so you are reinforcing, the software is reteaching you the material, so meaning that you're gonna get a good score on the assessment that you have in this particular unit. Okay, a summative, you're gonna have your class 1 grade for your percent of completion. You're gonna get a formative assessment grade for, I'm going to create this assignment in Google Classroom for your lab report, see, and you're going to get another formative assessment, because it's going to count formative assessment, it's going to count as a quiz for the score that you get on the unit test over here. See, that unit test, not the cumulative one. See, I'm not going to look at that unit test over here, in which, okay, classification of matter and physical and chemical change are going to be covered in that unit test. You're going to receive, okay, for the unit test, another grade. So 4 grade. Let's say that you decide not to do this, you're going to have 4 Z's on the grade book, because you are going to receive a grade for the summative, as a summative assessment for the overall grade that you get over there, assuming that you have 100% of completion. I'm going to give you a classwork grade for the percent of completion. Formative assessment for the lab report, because you're completing a lab report there, and another formative assessment for the score that you get on the unit test. Okay. So, being saying that, we have, remember, I'm repeating this one more time. You have this week and the next one after that due date. I'm not accepting late work. I'm saying this, I'm going to be serious about that. I'm going to document everything, okay? Everything. After that day, I'm not accepting any late work because I'm going to give you time during the lesson just to work in class on this. Now, this is the only thing that you're going to complete, all these assignments and all these assignments that you have in this unit. No, remember that I'm going to be dropping like a small assignments there in Google Classroom, and you're going to receive a grade for that too. And today we're going to start with the classification of matter. Okay, yeah, I'm showing you this. Can you see that there? Ms. Ramos, you're at the school. Yes, today during my planning day, I'm at the school. By looking at this picture, can you classify this matter? What can you say about this? You know what you're thinking. Oh, Ms. Ramos, that's a liquid. Okay, I know. You are using the state of matter to classify what I'm showing you. But I don't want you to classify that according to the state of matter. I want you to classify that according to the composition. Okay, Ms. Ramos, what do you mean? Do you know you have a compound over there? Do you know you have a pure substance? Do you know you have a mixture? What do you have in there? If that's the first assignment that you have in Google Classroom, okay, you were completing a vocabulary activity. You know the definition of a pure substance. Okay, I'm not going to repeat that because you have over there. The only thing that I'm going to say, the two examples of pure substance, we have elements, and then we have compounds. Ms. Ramos, do you have a compound in there? Do you have an element in there? I have to give you more information if you want to classify the matter. For example, that blue liquid is copper to sulfide. No, copper to sulfate. Okay. How are you gonna classify that blue liquid? I have to give you the formula. When you have the formula, what do you have in there? When you have a combination of two or more elements bonding together, you have a compound. Is that a pure substance? Yes. Okay. Questions about that? No? Okay. Now we're going to continue. Mixtures. If you don't have an element, okay, because Ms. Ramos is not giving you that information. Ms. Ramos is not giving you a piece of copper. Ms. Ramos is not giving you, I don't know, Ms. Ramos is not giving you 3 grams of salt, okay, which is sodium chloride. If you don't have that, if you don't have a pure substance, what is the other choice? Mixtures, and we have two types of mixtures. Homogeneous. And what is the other one? Heterogeneous. This is not new for you. I'm doing this, but you know, you were in my physical science class, you learn about all of this. Homogeneous mixture. Are you going to be able to see the difference between the components? No. An example of a homogeneous mixtures, solutions. You have solutions. Salt and water. Are you gonna be able to see the difference between the salt and the water? You're not gonna be able to see the difference between the salt and the water. So consequently, you have a solution. Questions about that? Heterogeneous mixtures. They are also known as mechanical mixtures. Mechanical mixture. Examples of heterogeneous mixtures. Suspensions. What else? Colloids. What else? What else do we have there in mechanical mixtures? I don't remember right now. Solution, remember, when you look at a solution, you're not going to be able to see the difference. Okay, because it's evenly distributed. Okay, usually it's when you have a compound that is dissolved in a solvent. See, in a solution, you're going to have the solute, mostly a solid, but not all the time. solute, and then you have the solvent. The solvent is going to dissolve the solute in a way that you're not going to be able to see the particles in there. If we're going to use that just to analyze when you have covalent, polar, and no polar compounds, because one of the rules of solubility is that lies dissolve lies. Okay, so mechanical mixtures, you have suspensions. Okay, you have colloids. Do you remember that? You don't remember that from physical science. Suspensions. Okay, remember that you go to the doctor because you have a bacterial infection, and then the doctor is prescribing you what? An antibiotic. But you don't like to take pills, so the doctor is going to prescribe, or the pharmacist is going to prepare for you a solution. When you are taking that medicine, you have to check that very well. I'm talking to me. You have to check that very well. And whether you have to check that, because if you leave that on top of your counter, what's gonna happen? Since the particles that you have there in the liquid are too big, if you leave that bottle on top of your counter for, I don't know, for 5 minutes, you know what's gonna happen? All the particles, they are gonna settle to the bottom of the bottle. That's why it's called a suspension. Those antibiotics that you have to shake very well in order to dissolve the solute, in order to put in contact the solute with the solvent, they are called suspension, because if you leave that settle for a period of time, you will see the solid collecting at the bottom of the container. Okay, listen, we're going to continue with mixtures, because remember that I told you at the beginning of the class, with today's lesson, you're going to be able to complete lesson 1, and then you're going to be able to complete part of the lesson number 3. Okay, mixtures. Remember that we have 2 types. We have homogeneous and then we have heterogeneous. An example of homogeneous mixture, solutions. So every time that you hear solutions in science, they are talking about homogeneous mixtures. Solutions, they are made of the solute and a solvent. And we were talking about the state of matter of the solute. Mainly it's going to be solid, but not all the time, because over here, as you can see, you have a liquid solution in which the solute is the alcohol. Now, what is the solute? The substance that dissolves. What is the solvent? The substance that is making the dissolving. Remember that when you went in physical science, we're defining the solute as the substance that is there in a small quantity. And I told you I don't like the definition, because sometimes you're going to have concentrated solution in which you have more solute than solvent, and still the solution is not saturated, and you have less solvent in that solution. Okay, so that definition of the solute is the substance that is in the smaller quantity there. That doesn't apply anymore to the definition of solute, because now we are in chemistry. Okay, the solvent is the one that is going to make the dissolution. Now we have different type of solutions. Okay, gas solutions, and an example is the air, because when you look at the air, can you see the difference between the different components? No. The air, by the way, is made of 75% of nitrogen, 28% of oxygen, and 1% of other gases. Other gases like dioxide, sulfur dioxide, nitrogen dioxide, carbon dioxide is there in the atmosphere too. So you don't see the difference. That makes air a solution. It's not a pure substance. No, it's a mixture. A mixture that is a homogeneous mixture in which the solvent and the solute, both the state of matter, gas. Then you have liquid solutions. Liquid alcohol and water is one example. And another example could be any vinegar, and water is another example, because that vinegar that you use in a home is a solution, 5% of acetic acid. So the acetic acid is covalent polar compound, so it's gonna dissolve in the water. Okay, in that case you have a liquid solution, because both solute and solvent, the state of matter, It's a liquid. Solid liquid, salt and water is an example. Sugar and water another example. Any solid that is ionic, you remember that from physical science, ionic compound, they dissolve in water, dissociating into ions. Okay, well, so when you have a solid that is an ionic compound, baking soda, dissolve the copper, let me put that over here, or let me show you that over here. That copper sulfate solution that you have in there, I know that you're looking at this color that I have over here, but that was because another chemical was left inside the bottle. But if you look at the blue liquid, okay, in this case, you don't see the water, you don't see the copper to dioxide, the copper to sulfate. So you have here an example of a solution of copper sulfate, because, okay, let me see, let me show you that one more time because the video wasn't on. See, you don't see the difference. When you look at the blue liquid, you don't see the difference between the copper to sulfate, which is a solid, and the water. Why is that happening? Because it's happening because copper to sulfate is an ionic compound, and the ionic compounds, they dissolve in water. Okay? And we are done with solid liquid solutions. Now, solid solution, example is steel and brass. And when you have a solid solution, the solid solution, they receive a name. They are called alloys. In one example is steel. In the steel, you have carbon, then you have iron, okay? But when you look at the steel, can you see the difference between the iron and the carbon? That's why it's classified as a solution. So until now, we were talking about homogeneous mixture. You know that homogeneous mixture, they are called solution. They are made of the solute and the solvent. Okay, now we're going to talk about heterogeneous mixtures. Heterogeneous mixtures are the mixtures that when you look at them, you can see easily the different components that are part of that mixture. Okay, we have different type of heterogeneous mixtures. For example, the most common one are mechanical mixtures. In mechanical mixtures, it can be solid, stay on matter of the entire mixture, solid, or the stay on matter of the entire heterogeneous mixtures can be liquid. Okay, solid. An example, you have an example over here. When you have a salad, let's say that you have tomatoes, you have lettuce in there, and then you have onions. Okay, if you don't want the onions, okay, you can separate that from there. Okay, if you don't want the lettuce in there, you can easily separate that from there, and keep that in mind because later we're gonna address that. Okay, for today we're covering classification of matter according to the composition. During the next class, we're gonna talk about the physical and chemical property. And you know that if you have tomatoes that are red and you have lettuce that are green, they have different coloring. What type of property is color? A chemical or a physical property? But we're going to stop over there. The only thing that you need to know until now is that within the heterogeneous mixture, you're going to have mechanical mixtures. The mechanical mixtures are the one that when you look at them, they're easy to separate. And the state of matter of that mechanical mixtures can be solid, when you have an example like this. Or let's say that you have, I don't know, rice and you have salt and you have sand in there. So easily, just to recognize the three solids that you have in their mix. Or we can have a mechanical mixture that is liquid. Now, liquid. We were talking about solution. In solutions, there's a lot of water involved. The solute was ready to get dissolved into the water. But what's gonna happen here when you have a heterogeneous mixture in which the components are liquids, and you are able to see that easily? That happens because the liquids, they are immiscible in each other. In other words, they are insoluble in each other. If that happens, okay, when you have, for example, oil and vinegar, you put them in a bottle, you shake that, still they don't mix. Why? Because the chemical composition of the vinegar and the chemical composition of the oil. Okay, they're not gonna mix. You put that on top of your counter, and in a couple of minutes, what's gonna happen? The more dense, one more time, what type of property is density? The more dense is gonna sink going to the bottom of the bottle, and the other one is gonna float in there. Okay? That's another example of a mechanical mixture in which the two components they are liquids. And then you have suspensions. Suspensions. We were talking about suspension when I was talking about the antibiotic. The particles, they dissolve in the liquid, but they are so big that when you leave that on the stove on top of your counter, what's gonna happen? The bigger particles, they're gonna settle. In one example is muddy water. See, it's all like dirty. It's all like I don't know, how do you call that? Cloudy. Okay, when it's mixed. But if you leave example on top of your counter, and in 5 minutes, what's gonna happen? The biggest particle of the big particles, they're gonna like settle at the bottom, and then you're gonna be able to see like not a clear, but a more like a more clear liquid on top of your suspensions. And then we have colloids. One example of a colloid, milk. Oh, Ms. Ramos, now we're very confused over here, because you're saying that when you have a solution or a homogeneous mixture, when you look at the substance, you're not going to be able to identify the different components. If I look at milk, I'm not going to be able to identify the fatty acid. I'm not going to be able to identify the water that is in there, the carbohydrates, the glucose that is in there. I'm not going to be able to identify that. Okay, a colloid is a heterogeneous mixture because even though you don't see the difference, they are on the solid particles in there. Okay, how are you going to differentiate a colloid from a solution if that was part of your vocabulary activity? If you were in my physical science class, I was showing that to you. If you want to do that at home, you can do that. Get a glass of salt and water, flashlight, and put the flashlight in front of the glass with salt and water. You will see that the light will go through. Okay, because since you have a solutions, all the particles are dissolved evenly in there. Now get a glass of milk and do the same, and you will see that the light doesn't go through. Why? Because the particles that are still on dissolved in that liquid, they are gonna deflect. See, reflect the light back to you, and they are not gonna let the light go through the mixture. Okay, that's what we call the Tyndall effect. Questions until now? No questions. Ms. Ramos, you were talking about immiscible and miscible, and you said that immiscible is a liquid that is insoluble. And what about with miscible? Okay, in solutions, you have miscible liquids. When you're talking about liquid and liquid solution, alcohol, you have to keep that in mind, that we're talking about miscible when we're talking about liquids. We're talking about solids. We're not talking about that. We are talking about miscible when we're talking about liquids and gases. Okay, so because those are the ones that are considered fluids. Okay, so alcohol. If you put alcohol in a glass, let's say that you're putting 5 milliliters of alcohol and then you're adding 20 milliliters of water, what's going to happen? Are you going to be able to see the difference? No, because alcohol is miscible in water. But if you get the same 5 milliliters of alcohol and you mix that with 25 milliliters of oil, both they are liquid, but are they gonna mix? No, because alcohol is immiscible in oil. And later you will know why, even though I was explaining that in physical science, and it has to do with the polarity of the molecule when they are bonding. Okay, questions? No? You don't have any questions. We are gonna finish for today. So far we have covered classification, the classification of matter according to the composition. Okay, tomorrow no, during the next class, we're going to start with physical and chemical properties, physical and chemical change, and then we're going to discuss the lab, and then I'm going to continue with material that are part of the unit but still is not explained on Genuity.